Powder coating fundamentals. Powder coating is the process of spray painting small particles of electrostatically charged pigment and resin onto metal using a manual or automatic spray gun. The coated metal is then cured with heat to create a hard finish. Powder coating is preferred over wet painting due to its quicker process and more durable finish. There are 4 main types of powder, and MPE uses all of them: epoxy, polyester, acrylic, and fluoropolymer. Safety and health hazards. Safety is an important element of the powder coating process. MPE requires employees working at the powder coat booths and/or handling powder to wear safety glasses, ear protection, and a dust mask. Arms must be covered up to the elbow. Anyone handling powder material is required to wear a dust mask and either prescription safety glasses or goggles. Gloves are optional. Protection is needed with opening powder containers, filling supply bins, and cleaning equipment. Proper washing of skin after powder exposure is important, especially before eating, drinking, and using the restroom. No food or drink is allowed in the powder coating booth. Any employee who would like more information in regards to the safety precautions and health hazards associated with powder coating materials can access the SDS safety data sheets in Providex. Wash process. Most parts go through a 5-stage wash system prior to powder coating. 1. Phosphate wash. 2. Rinse. 3. Phosphate wash. 4. Rinse. And 5. Non-chromate sealer. Powder coating booth. MPE's powder coating booth has 2 separate stations on either side for 1 operator each. The first station is for the inside painter. Since it is standard practice to paint the inside of the part first, the inside painter is positioned before the outside painter. This is why it is important to always hang parts on the line in the same orientation. It is also important to minimize open spaces in the booth to prevent cross-contamination of powder materials. Powder coating guns and control boxes. Let's quickly review the parts of the powder coating equipment. The first part is the powder coating control box, which includes preset settings, powder flow control, KV and UA display button, STD/AFC display button, and air atomizer control. Secondly, parts of the powder coating gun: sleeve, fan tip, electrode assembly, hose connector. Powder application preparations. Gun and control box setup. Always inspect guns for worn or broken parts before using. Anytime a gun is dropped, it needs to be properly cleaned to remove any possible contamination that could end up on the parts. Generally, the powder flow should be set to 40 psi and the air atomizer to 30 psi. Powder flow may need to be adjusted based on part geometry. Voltage should be set to approximately 90% or 50% during rework. The control boxes have 3 preset settings: recoat, metallic, and deep cavity. The deep cavity setting will be used most often. While using this setting for painting a deep cavity, the STD standard mode button should be lit. When you are not painting a deep cavity, press the STD/AFC button so that the AFC automatic feedback control button is lit. The AFC setting automatically controls the charging voltage based on the gun to part distance. Line speed. Line speed is measured in feet per minute and can be adjusted based on part configuration. Gun speed. Gun speed is crucial to proper powder adhesion. The guns we use work by charging particles after they pass through the gun tip. This means if you are moving the gun around a part too quickly, the powder will not have enough time to become charged and adhere to the part. On the other hand, moving the gun too slow will result in excessive paint and/or back ionization. Gun speed may need to be increased when painting small areas. As a general rule, you should be moving the gun about 12 to 18 inches per second. If you feel as though you are working too hard while painting, you are either moving too fast or the line speed needs to be turned down. Gun distance. Gun to part distance is important similarly to gun speed. Ideal gun distance for powder coating a flat surface is 6 to 8 inches from the part. Distance for smaller recessed area may be as close as 3 inches from the part. Gun distance too close results in streaks, runs or sags, orange peel, and uneven film thickness. Gun distance too far results in light coverage. Painting technique and pattern. Once an acceptable painting pattern is established for a part, every powder coater should be using the same technique to ensure consistent results. Refer to part-specific work instructions for proper techniques. It is important to overlap your strokes on the first pass to create a smooth finish. Things to consider before powder coating. Is the line speed sufficient for my pace? Not too fast, not too slow. Is the gun set up correctly based on the part and type of powder? Do I know what myself and my partner are painting? What features of the part's geometry may be difficult to coat? Bends, seams, corners, recessed areas, hook marks? What issues have we had with these parts before, and how can I avoid defects from happening? Do I need to apply more or less powder depending on specific paint type or color? If you're not sure, ask. Booth cleaning process. The booth is cleaned between each color or powder type. 30 hook gaps are left between colors. Sweep walls, spray walls with air hose. Sweep floor. Collect powder and place in waste box. Bake down waste powder. Dispose. Do not use air hoses for cleaning guns or booth during the run. This can contaminate the parts going through the booth. Curing process. After powder application, the line carries parts into the oven for curing. Oven temperature varies depending on powder type and part geometry. Definitions and terms. Back ionization. When excessive deposits of charged powder particles prevent further powder from being deposited. This can happen during the first coat, but is more commonly associated with recoats. Causes. Voltage too high, gun to part distance too close, insufficient ground, excessive film thickness. Effect, orange peel. Faraday cage effect. This effect can happen while powder coating a part with a deep recess or channel on its surface, causing the powder to follow the path of lowest resistance to ground. This results in excessive powder buildup on the edges of the part and minimal coverage on inside corners and cavities. Causes: improper grounding, gun tip, spray pattern, voltage setting, PSI setting, gun to part distance, and particle size. Transfer efficiency: the amount of powder that adheres to the part compared to the amount of powder that is sprayed from the gun. Ideal transfer efficiency of powder is approximately 90%. Orange peel: surface finish defect caused by back ionization. Fish eye: defect caused by surface contamination on part. Run or sag: defect caused by excess powder deposits.